All right. You guys want to come up? All right. So I have two very easy questions, and I want to see if you guys could get at least one. I'm sure you guys could get both, though. They're really easy. So this first one, I have 3 water bottles, and they're halfway filled with water, and I painted the water blue with food coloring just to make it easier to see the water. So another thing about these water bottles, they're all at rest. All of these water bottles are at rest. I want to see if you guys can tell me what's the difference between these 3 water bottles. I'm showing them to you.
This one's upside down, this one's right side up, this one's on its side.
You got it, yeah.
Okay.
How did you know, if I may ask?
Just because the water levels.
The water levels, exactly. Yeah, the water shows you the correct orientation, especially, right? Another thing about water, it's when it's containing at rest, it always levels out, like you said, right? So what could be you guys' definition for level?
Sorry, can you repeat that?
What will be your guys' definition for level? Or like,
I'd sort of say where something is relative to a measurement.
So for example, if you have a level surface,
flat,
okay, that's a good one. The one-word definition will be horizontal. So level is perpendicular to the vertical, 90 degrees from the vertical. That's what level would be. And another definition will be no deviation in elevation from one point to any other given point. So again, water, when it's at rest and contained, it always levels out. So exactly. So since we understand what level means, this one's even easier. Which one of these two represents level as we know it when it's contained and at rest? A or B?
A.
Hey, that's the obvious one, right? So the real reason I'm doing this is because over 95% of the population, including myself and maybe you guys, have been tricked to believing this is what level means, even though we know is this, and water shows us that.
Yeah.
You guys want to know how we were tricked? Do you guys believe the Earth is a ball in outer space like this?
Yeah, I believe that.
Yeah. So NASA, they claim to have satellites orbiting the Earth. That's why they take these images. So they claim to know the radius of orbit. So they need to know the radius of the Earth. They're supposedly going around it. So they do tell us the radius of the Earth is 3,959 miles, which means there has to be curvature every mile, and every mile it has to increase because they're claiming it's a curve, not a slope. So in the first mile, they should be at 8-inch drop, second mile, 32 inches, and by the third mile, they should be 6 feet of curvature. So in 10 miles, there should be 66 feet, which is like a 6-story building. So if we went out to like a giant body of water, like a lake that was miles across, they're trying to tell us that the surface of water is bending 6 feet in 3 miles when it's at rest, but the reality is that water is always level when contained. Again, it always forms an equal surface.
So we've been tricked into thinking it's this, but it's actually
this. Water never bends once it's contained, like in your cup. The surface, you know, especially once you have a large body of water, the surface cannot maintain itself because water has no form. So it just basically collapses and forms an equal surface, which will be level or horizontal, in other words. So this will be the #1 experiment to debunk the ball Earth. It's a physical measurement of the Earth, water in specific. Because there's lakes on Earth that are easily over 20 miles. So all we need is a few miles to be able to measure that surface, because every lake on Earth should be bending at that curvature rate, because that's the radius that we're given. So respectfully, if I was to ask you guys, what's the #1 proof that makes you believe that the Earth is a ball? Or the #1 reason?
That's what it is. I guess gravity, maybe?
Gravity? I'm glad you brought up gravity. So if I was to ask you, what is gravity?
So gravity is when a certain object of a certain size is able to have other objects.
Okay, could we say that, so you think gravity is a force?
Yeah.
It's a force, right? Because obviously when you release an object into free fall, there's an apparent acceleration that we witness, right? So in order to have acceleration, you need a force, right? I don't know if you knew this, but Einstein's theory of relativity claims that gravity is not a force. Yeah, so the thing is, the reason why they did that is because when you release an object into free fall, there's nothing causing it to accelerate down, because in reality it's not accelerating down. So the force, gravity, that they claim the Earth's force is not a pulling force, it's a pushing force. So this is where they basically they mix it in with the truth, basically. So the truth is the only force that exists is a push. So if you want to move any object in reality, something else needs to be able to move it. So something needs to push on something else to cause motion. That's how every combustion engine works. That's how you ride your bike. That's how you have the chain. It's all leverage. So something needs to push on something else to make it move.
Well, what about the moon?
No. So that's all just theoretical. So the reality is, when you release a helium balloon, what direction does it go?
Up.
Why do you guys think it goes up?
Just lighter than air.
What about it being lighter than air? What about the air being heavier that makes it go up? But what about it being less dense that makes it go up, that accelerates it? Exactly. So the air is pushing up on the helium balloon. So what's pushing up the air?
Nothing's pushing there. It's here.
It is. So the Earth is actually pushing up on it. So you're not being pulled towards the Earth. It's the Earth pushing up against you. So that's why we have a pressure gradient with in the air. That's why we have a higher pressure lower on Earth, and it decreases the higher you go. That's because the Earth is in motion. So that's what's creating that pressure gradient. So that's why helium balloons go up. So if we can prove that the force is up, the pressure is up, the Earth is moving up, how does that work from a globe? If objects don't move down towards the Earth and it's the Earth pushing up against the objects, how would that work from a globe?
I guess it would have to be flat.
It wouldn't work from a globe, would you agree? If it's the ground, if we could prove that it's the ground pushing up.
If it's true that it's pushing up, then I guess it would be flat.
Well, level, I would say, because again, level is an orientation relative to the motion, which is the vertical.
Yeah.
So that's why water's level, because it's perpendicular to the motion vector, which is, again, the Earth cannot be moving, cannot expand in all directions at once. It would explode the globe. The fact is, the Earth is a level plane, only moving in one direction, up.
So you personally believe that the Earth is flat?
Well, I don't believe it, I understand it, because that's what reality shows me, water in specific.
Wait, just out of curiosity, like, if the Earth is flat, why do they tell us that it's a globe?
Well, it's about control. So they tell you that it's like a cheap shot in your common sense, so that you accept authority as kind of like to tell you what to do in a way. So when you grow up, you kind of have that same mentality that you think other people are smarter than you, so you're just gonna do what you're told. It's about control at the end of the day. That's why they tell us. It basically cripple us mentally.
That's interesting.
Yeah.
So, do you think the moon is round?
So the moon, nobody knows what they actually are, because nobody's actually been higher than around 25 miles. So everything higher than, and the reason why is because in order for any flying device, an airplane, helicopter, they push off of the air. So the air needs to be at a certain density to be able to get lift off of it, because you got to push off of the air. The higher you go, the less dense the air gets. So aircraft can only fly so high because they're not able to push off of the air. So helicopters cannot fly up forever.
So you don't think the moon is real?
Oh, no. That was literally one of the main reasons they pushed that film, was to make people believe that they live here. So that we disregard physics, water was showing us that, that this is impossible.
Yeah.
Especially because gravity, again, it's not, that's why gravity as a pulling force is always going to be a theory. So Einstein and Newton are both wrong, because the fact is objects don't accelerate towards the Earth. What's happening is, right now we're all moving with the Earth, it's all in motion. So as soon as you release this, it starts to lose momentum. So the Earth simply catches up to it. So it's still moving up, but to us, because we're moving with the Earth, it looks like it goes down. But it's actually still moving up, but it's slowing down. So it's like when you're driving in a car 100 miles an hour and there's another car driving next to you 100 miles an hour, and they let go of the gas, what happens? It looks like they're going backwards. But in reality, they're just slowing down. So again, anything that's not connected to the Earth, it starts to lose momentum from the Earth's motion. So again, this doesn't accelerate down. It's the Earth that just comes up to meet it.
That's an interesting point, but I just wonder what you make of the sun, of the Earth, like what you think of that.
I would say that's a separate discussion. If you want to establish the dimensions of the Earth, I would say that's a red herring, looking at the stars. Because at the end of the day, looking at the stars is not going to tell us a physical measurement of the Earth. If you want to know if the Earth is truly bending or not, a physical measurement like this over a body of water will be the number one experiment.
But like, if you had to say, when you say the moon is flat?
The moon, I would say, is a circle. But a circle, again, we only see in two dimensions. So if you're seeing a circle in front of you, you don't know if it's a cylinder, you don't know if it's a sphere, because you can't go around the other side, because we only see in two dimensions. So when it comes to the sun and the moon, I acknowledge that there are lights in the sky and they exist, but they're not solid, in my opinion. They're not, like the moon is not a terra firma. It's just a light, in my opinion.
What do you think is at the edge of the Earth?
Okay, good question. So a lot of people talk about the edge, right? So outer space as a vacuum defies physics, and I'm gonna tell you why. In order to create a higher pressure here, or even a vacuum here, we need a solid container. And the reason why we need a solid container, because if there's a hole in that container and we have a high pressure, the air's gonna start to rush out and start to equilibrate with the air. So in order to have two opposing pressure systems, you need a solid barrier. So the claim that outer space is a negative pressure next to Earth's pressure without a solid barrier, that defies physics. So the Earth is a contained system. I just don't know what that container looks like. So when you ask, well, what's at the edge? I would say, well, what's at the end of the Earth will be a container, but nobody's actually been there to verify it. But again, we couldn't have air pressure without containment, and we have air pressure here on Earth, meaning the air is being maintained somehow. Again, they use gravity as a pulling force to explain away all these phenomena, But the fact is, they have to push gravity as a pulling force because they require that acceleration down towards the center point to sell their entire model. Because if it's the Earth pushing up against you, how do they explain outer space and orbits and all that? Again, even a globe, it just wouldn't work, expanding in all directions. That's, I mean, for a lack of a better term, it's pretty retarded.
Yeah.
You know what I'm saying?
Yeah,
and that's why, again, gravity's always, they acknowledge the upwards force. They call it a normal force. That's what they call it. But the fact is that normal force is the Earth's motion. And the downwards force doesn't exist.
So do you think we're always moving up?
Yes. Yes. So when you let a helium balloon go and an apple go, the air's not dense enough to push the apple up like it does the helium balloon. So again, the apple just loses momentum. Anything that the air can carry will get pushed up because that's the direction of the force.
Well, then what's pushing us up?
That's good. That's a good question. What's pushing the Earth up is what you're saying, right?
Yeah.
Well, this is an intelligently designed place. So whatever created this place, put it into motion. So I don't know the mechanism of the Earth's motion. You know, some people like to make fun of it, like, oh, you know, they must have an engine somehow, which, I mean, you never know. It could, you know. It could be some part of leverage system that's propelling it. I don't know. At the end of the day, it could be some electromagnetic field that the Earth is moving through, you know. At the end of the day, nobody knows the mechanism of the Earth's motion, but physics shows us that it is moving because we wouldn't have buoyancy. So again, can I show you guys a real video that I just filmed?
Sure.
So a helium balloon obviously goes up, right?
Yeah,
so
can I ask
Sure,
a question?
real quick.
So I saw this video on YouTube the other day. It was about military snipers.
Okay.
And it was
yes.
talking about how they're designed so that they actually measure the curvature of the Earth
Yeah.
when they shoot people. So how would you explain?
You're talking about the Coriolis effect.
Yeah.
Yeah, Coriolis. So that's actually a myth with snipers. All they take account for is, I guess, what do you call it? Because obviously, airspeed, basically. That's all they account for, the airspeed when the wind's blowing left or right, you know, and obviously the declination of the bullet, you know, but that has nothing to do with Earth's spin. So that's what you're talking about, how they calculate Earth's spin when they shoot to be able to hit targets. They don't calculate Earth's spin.
So they're calculating its spin.
That's what they claim, but in reality, if you real sniper interviews, I guess, or people that they admit that they don't take account of Earth's spin when they shoot.
Oh, so you think sniper companies are kind of making this up?
If they are claiming it, they are making it up because real snipers that actually are out, you know, doing it practically, they say that they don't take account of Earth's spin.
And it's the military, which is government.
Sure. Again, that's another thing. Yeah, exactly. So here, let me show you this real quick. They're really short. So I recreated buoyancy in a van, and look what happens to the helium balloon. What direction does it move? So I have an apple that's more dense in the air and a helium balloon that's less dense in the air. What direction would you guys say I accelerated the van? Right or left? Or forward or backwards?
Oh, where's the apple?
The apple's red right there.
I'd say the car is going that way.
Exactly, yeah, it is. And the reason why it's going that way is because when I accelerate, the back of the van, the door that's closed, starts to create a pressure gradient, starts to push the air that's in the way, and then that air starts to push the helium, which is less dense in that same direction that car's moving. So if we invert this way, it's the same principles when you let an apple go and a helium balloon go. It's the Earth creating that pressure that's pushing the air, that's pushing the helium up. So again, it's the Earth's motion. And I'm gonna tell you, the flat Earth, I know you guys heard of flat Earth, right?
Yeah.
So that is the biggest psyop, well, besides the globe Earth, because over 95% of flat Earthers have been convinced that the Earth is motionless. So they deny that there's a cause to things falling. So they get into some pretty stupid explanations that just make this whole thing look ridiculous, and that's how this thing's being controlled. So all the mainstream flat Earth channels claim the Earth is motionless, which is just bullshit, and that's how it's being suppressed.
That's interesting.
Do you believe in the ice wall?
Oh no! The Antarctic ice wall. I know they claim that. I don't buy into anything that I can't verify for myself, but there is something containing the water. I just don't know what that is.
But don't you think that, like, there are 8 billion people in the world, don't you think at this point someone can have some sort of photographic documentation of the Earth?
You mean like a whistleblower is what you're saying, or what are you talking about?
Yeah, like I feel like at least someone would maybe like take a ship or something and see that.
Oh, I see. So this is where a lot of stories from the military come into play to kind of fill in that gap for people. But again, they're just stories. Apparently, the military has gone down to Antarctica since like the 40s, 50s, and they claim that they maybe found something that they didn't want to show us, maybe more land, maybe the container, you know. But that's when they established NASA, and then basically started lying to people that we live on a globe instead of an extended plane. So they're trying to hide whatever the hell they found. So I think they have explored this place, and maybe they did find something that they didn't want us to know. You know.
How do you think, like, if the world's always moving up, how do birds fly?
Oh yeah, that's easy because they push off of the air. They require buoyancy. Buoyancy is the air pushing on anything that's less dense. So they have to expand their wings to create a larger surface area, and then relative to their mass, the air is able to push up on them now. So it all has to do with surface area and buoyancy. And then obviously they flap their wings, you know, to push off of the air up. So same thing with helicopters, you know, they push off of the air, you know, to maintain lift. But again, they could only fly so high because the air gets less dense. And again, that's why space travel is impossible. It wouldn't work. You wouldn't, and a spaceship wouldn't be able to push off of anything to move forward in space because you need the air.
Push off of air?
Well, that's why in space they claim there's no air. You know, that's the point. Yeah, because airplanes push off of the air, helicopters, everything pushes off of something else to move. You know, so again, it's the Earth's motion that's pushing up. You know, so no, yeah. One more thing before you guys go. Another thing is, how would you guys describe the horizon?
The horizon?
Yeah, this is the horizon. Obviously, this is a horizon too at sea level, but this is 20 miles in the sky. How would you guys describe it?
That's flat.
Horizontal, I would say that's the word where the word horizon comes from, in my opinion. And again, if the Earth was a globe and we're standing on top of it and it was curving down, the more we elevate, the more that horizon should drop below your feet. You know, and that never happens. What happens is when you increase your altitude, you're only increasing your angle of view and you're able to see further in front of you. So that's what's happening. Either the horizon or the sun, even when the sun's going down the horizon and you elevate, that sun should go down below your feet when you elevate, but the fact is it rises with you. So the horizon is only apparent. It's the limit of our perspective. So here, you guys
We gotta go back to work, but
here,
yeah,
let me
nice
take my,
meeting you.
yeah, meet you guys.
Yeah.
Here, take my flyer and check out my other conversations. I go to UCR, UC Irvine.
Yeah,
I go
that's
to other.
cool. Is this going on YouTube or anything?
Yeah, check it out. I'm
cool.
live streaming right now, so you can check it out.
Oh, nice.
Yeah.
What's the channel called?
It's right there in the front,
On the front?
right there. You could scan it or look for it in the bottom.
Oh,
Level-headed
yeah, I'll
William.
scan it. Awesome. Thank you.
Amen.
Nice meeting you.
Yeah, no problem. Take care.
Good, sir.
Hey man, how's it going? I mean, you heard a little bit of what I was
Yeah.
talking about, right? So,
NASA.
so, I mean, I can ask you this question.
Yeah.
I'm pretty sure you didn't see this question, but you want to get this shot?
I do.
Sure. Okay, so two very easy questions, and see if you could get at least one, right? So, I have 3 water bottles here, and they're halfway filled with water, and they're all at rest. So, how I'm showing them to you, what's the difference between these 3 water bottles?
How they're laying.
How they're laying. Okay, can you put them in the correct position? What's the difference between how they're laying?
Yeah.
Oh, actually, this one's 3 and this one's 2. Yeah.
Yeah. Here, this one's the water like this. Wait, how buoyant is this?
No, yeah, that's just a ping pong ball.
Okay.
Yeah.
Then yeah.
Yeah, you got it. You got it. So, how did you know that
Yeah.
that's the correct position?
Floating.
Right, because the water can go to the
Yeah.
top, right?
Yeah,
That's
yeah.
obvious. Yeah, you got it. So another thing about water, when it's contained and at rest, it always levels out, right? Would you agree? What could be your definition of level? Or your
A right angle.
A right angle from the vertical.
Or 180.
90 degrees from the, or one, yes, 90 degrees.
90 degrees,
from the vertical, that's a good one. Or the one word definition will be horizontal.
Horizontal.
Because horizontal is perpendicular to the vertical, which is level. Perfect. So since we understand that water is level and contained and at rest, which one of these 2 represents level as we know it? A or B? Yeah, we do. Okay. So the real reason I'm doing this, and I know you already heard about this a little bit, is because over 95% of the population, including myself and maybe you guys, have been tricked to believing this is what level means, even though we know it's this, and water shows us that. You want to know how we were tricked?
What? Yeah, well, how would that be level though?
Exactly. Do you
I'm
believe?
saying like who thinks that's
Do you
level?
believe the Earth is a ball?
Yeah.
Yeah. So
it
NASA. So NASA claims to have satellites orbiting the Earth, right? So they need to know the radius of orbit. So they need to know the radius of the Earth if they're supposedly going around it. So they do tell us the radius of the Earth is 3,959 miles, which means there has to be curvature every mile, and every mile it has to increase because they're claiming it's a curve, not a slope. So in the first mile is an 8-inch drop, second mile 32 inches, and by the third mile it should be 6 feet of measurable curvature. So if we went out to like a giant body of water, like a lake for example, to physically measure the surface, they're trying to tell us that the surface is bending 6 feet in 3 miles, but reality, water is going to show us that that's impossible. that once water is contained, like on a lake, the surface is always going to be a perfectly level surface.
Flat.
Exactly, or flat, you could say. But this will be the #1 experiment to debunk the globe, a physical measurement of the Earth, water in specific.
What about like what's it called? Where it's like sticks to things.
You're talking about surface tension, kind of, or
Yeah.
Vision or
yeah, there you go.
Like,
that only
on your
happens.
water bottle, you can
Yes.
see it's higher than what the level.
That only
actually
happens
is.
at a very minuscule, when very small amounts of water. Even a cup, right? You can fill it up to the rim and it kind of bends a little
Right, but
bit.
it's gonna stick, so you're not. I mean, if it's
No, but-
level, it's still gonna.
Well, we're
stick
talking
to all
about
the other
we're
molecules.
talking about large bodies of water, though.
Yeah.
For example, a pool. If it was to extend that pool, that surface is always going to collapse and form an equal surface.
Mm-hmm.
At no point will that pool ever start to bend and stay bent and maintain that bend.
Right.
Because that's physically impossible. That's like claiming you could walk on water. That
Right.
defies physics. You know. So if you claim to me that water does bend at a certain distance, well, then you got to show me that, because reality shows me that that's impossible. And that's why a physical measurement will never be talked about in the mainstream. And they'll always just focus about looking at the stars and the sky, because that doesn't prove anything about the ground. So they're just red
So-
herrings.
Do you think that the Earth is flat?
Well, I don't think it is. I understand that it's a level. Flat is a psyop, and I'm going to tell you why in a minute. But basically, over 95% of flat earthers are claiming now that the Earth is motionless. So in other words, they don't have an explanation, or they deny the fact that there's a cost to why things appear to go down. So they are completely lost. So that's how they're controlling this information. The fact is, gravity, they claim it's a pulling force, right, of the Earth. The fact is, pulling forces don't exist. So in order for something to have motion, you require pressure. So something needs to press on something else to cause motion. That's how combustion engines work, and everything else that has motion works. So if you want to move this, you got to apply pressure and to move it. That's push.
That's not what gravity is, though.
Well, they claim it's a push or a pull, but
Right.
pull doesn't exist, because what's the mechanism of pull if not pressure?
Gravity is the attraction of molecules between each other, and the reason why we're stuck on this Earth is because the Earth is the largest thing to connect us.
Right. So if
So how would it's not movement,
Right.
it's attraction.
but it's creating movement, isn't it?
Sure.
When I release this, you believe this accelerated down towards the Earth because of
Yeah.
Earth's mass, right? The fact is, the Earth didn't pull this towards the ground. The Earth actually pushes up on you. So you're not being pulled towards the ground. It's the ground pushing up against you. So that's what gravity is. It's a push. So the Earth is actually moving you, not pushing up against us.
Okay.
Yeah. So, and even Einstein acknowledged this. I don't know if you've heard of Einstein's theory of relativity. He acknowledges that gravity is not a force because of that fact that there's no. So you have you know what an accelerometer is, right? It detects acceleration. Everybody's cell phone has one. You can download the app, right? And it detects acceleration. So anywhere you move it, it's going to detect that acceleration. When you put it into free fall, however, it detects zero acceleration because it's not being accelerated down. Again, it's just moving with the Earth. When you release it, it starts to slow down. So it starts to lose momentum, and the Earth catches up to it again.
Interesting.
So that's the reality. So pulling forces don't exist. It's a push.
I'll have
So-
to look into it.
No, you definitely
You
should.
propose that B is a level.
Anybody that believes the globe or claims the globe. Because water, have you ever heard of sea level?
Yeah.
Yeah, so you would have to believe the oceans are bending around a ball like this. But the reality is the oceans are level and the continents are just across the way.
So A or B, who's claiming that the world is flat? A or B?
Well, reality shows us that the Earth is level or flat. I don't know if you want to use that word. But they're trying to tell us, our education system, to ignore our common sense and ignore our reality and just buy into this cartoon that they show us right here. And they admit they don't take real photographs, by the way. This is an image, and they have to call it an image because it's not a photograph. So, and they admit, again, that they're all CGI. They make all of these images in a computer generated. So
This is not a real photo?
no, but this is an official NASA image. Again, and they admit they don't take real photographs. Their excuse is that they can't go high enough. That's their excuse. So you got to ask yourself, well, how did you guys do it in the 70s? Exactly. It's all
With
bullshit.
with the moon and all that.
Exactly.
Armstrong.
Exactly. So they claim that's the only real one from the moon landing. But in reality, you have to believe that whole thing was real, first of all. And again, if you show me an image that defies physics, like if you show me an image of you walking on water or flying, I'm going to dismiss those images. Unless you could show me practically in reality that happening, then I'll accept it. But that's not going to happen.
That's physically impossible.
Exactly. So the globe is physically impossible because water just can't do the things that they claim to do. You know, and like I was showing the last group,
Yeah.
a helium balloon goes up because the Earth is creating that pressure gradient in the air, and the air is pushing up on the helium. So it's like a chain reaction. So the Earth's motion is creating the pressure on
It
Earth.
also has to do with density, right?
Well, yeah, if something's more dense in the air, then it can't push it up, so it just appears to go down. And something that's less dense in the air, like a helium balloon, go up. Here, let me show you this video I did. I had an apple and a helium balloon in a cargo van, and I accelerated the cargo van. Can you tell me what direction I accelerated the cargo van? If we know, so you can see the apple and the helium, right? So forward or backwards?
Both balloons or just one?
That's just one balloon, helium balloon, and then the other one is an apple, which is more dense, obviously.
Oh, that's an apple. I thought it was
A little balloon, nah, it's an apple.
I would say to the left.
Wait, you think I accelerated that way?
Yeah.
Nah, the reality, I accelerated this way. So what happened was, when I accelerated this way, the back of the van started to push the air that's right there, taking up the space. And what happened was, that air started to push the helium, because it was all being pushed by the van. So the air's not dense enough to push the apple, so the apple wanted to remain still. So it looks, because the camera's mounted onto the car that's moving, it looks like there's two motions, like the apple goes back and the helium balloon goes forward. But in reality, only one of those objects actually moved, which was the helium balloon. The apple only wanted to, if you were looking at it from the outside, the apple kind of stood in place while the whole system was moving. So the apple only appeared to go back because the whole system was moving.
I got
Does
it.
that make sense? So we're connected to the Earth. So when you release an apple and you release a helium balloon, the whole system's in motion. So the apple's just going to look like it goes down, and the helium balloon is exactly. So if you believe in gravity, you have to believe that gravity is like a double force. It can push things down and up at the same time,
Yeah, I believe that.
which defies physics, if you ask me. You can't have something moving opposite directions at the same time.
This makes sense.
Exactly. So the only force is up, you know, and that's the only measurable force.
Yeah.
Buoyancy is an effect of a force. And I don't know if you knew, buoyancy vanishes in free fall. If I could show you this real quick. So, just real quick. In this experiment, I was holding this helium balloon. Just before you go, this helium balloon, when I'm holding it, it's being pushed up by the air inside the box. But as soon as I release it into free fall, that upwards push is no longer felt, and the slinky retracts again.
Because if it wasn't in a box, it'd go up.
Yeah, if it wasn't in a box,
Right.
it'll go up, exactly. But as soon as I put it into free fall, the air's not able to push it up because the box is in the way. That helium balloon,
If it's heavier, it's gonna drop.
yeah, the box is heavier. But my thing is that the helium balloon inside the box doesn't get pushed up while it's in free fall.
Okay.
So again, buoyancy is an effect of an upwards force.
I see.
You know what I'm saying? So, I mean, you have any questions before you go? I mean,
No. Did I pass the test?
oh yeah, man, you got it. I mean, you know, you got it. I mean,
I gotta.
here, let me give
My
you.
mom's getting her teeth done. So.
Here, let me give you my flyer.
Okay, cool.
Inside of the 6 main proofs that debunk the globe. And yeah, that's my channel in the front. And I have
YouTube?
yeah, that's my YouTube right there. I'm super censored on YouTube, by the way. So
That's good.
Yeah.
What was your name?
My name's William.
William.
Yeah,
Elias.
yeah.
Nice to meet you.
Thanks for the chat, man.
Yeah.
Yeah, you take care.
Take care.
Yeah, you too.